Okay, so what does the quotient rule say? This is the quotient rule for general tensors. It says that if the inner product of an arbitrary tensor with a given entity is a tensor. So product of an arbitrary tensor with a given entity, and the answer is again a tensor. It means that the entity is also a tensor. This is what the quotient rule says. The statement is the same for Cartesian tensors as well as for general tensors. So to understand this better, let us look at an example. Okay. So where should I write? Okay, I should write from here. So example, if we are given that T subscript ij Vj equal to Ui, where this V is an arbitrary contravariant vector, is an arbitrary contravariant vector. Contravariant vector, and this U is a non-zero covariant vector, then Tij is a second rank covariant tensor. Okay, so here is one example. So what are we given here? We are given that, so let me change the color here a bit. We are given that this V is an arbitrary contravariant tensor, contravariant vector, and this U is a non-zero covariant vector. And here we see that we multiply this contravariant vector V with an object, T, which has two lower indices ij. Okay, so when I multiply V with this object T, and then I contract the indices j. Okay, I contract the indices j, and the result that I obtain is again a vector. It's a covariant vector. Then it means that this object TIA should be a tensor. Okay, so here Vj is a tensor of rank 1. Ui is also a tensor of rank 1. So here I have a tensor, and we take the product of the tensor with an object Tij, and then we perform this contraction over one index, and then the answer that we obtain Ui is again a tensor. Then according to the quotient rule, this object Tij should be a tensor. Okay, and then we'll also see that this Tij is a tensor, and it is a second rank covariant tensor. Okay, so let us see how we can prove this. So let us start with this Tij, this product. Let us start with this product in the prime frame. Prime frame. So T prime alpha beta V prime beta. This is the product in the prime frame. And this is equal to U alpha in the prime frame. So this is what is given. Okay, T alpha beta V beta. If I contract over the index beta, then I get U alpha. So this is what is given. This is this given condition in the prime frame. Okay. Now it is also given that this U alpha, it is a non-zero. It is a non-zero covariant vector. Okay. So U is a non-zero covariant vector. So what is the relation between the components of U in the prime frame and the components of U in the unprime frame? So this will be dou xi divided by dou xi divided by dou x prime alpha, dou x prime alpha ui. Correct? So this is the transformation rule for a covariant vector. Okay. So how do we check whether this Tij is a tensor or not? To check whether any quantity is a tensor or not, we just see whether it satisfies the conditions for a tensor under coordinate transformation. That is, whether it satisfies the transformation rule for tensors. So we want to see that. So if we want to see the transformation rule for Tij, so we start with T alpha beta V beta in the prime frame, that is equal to U alpha prime, that is given. Now we apply the transformation rule for U. And since U is a covariant vector, that is a covariant tensor of rank 1, it transforms according to this transformation rule. This is the tensor transformation rule that we already know. And this UI, we can see that it is given that this UI is simply the product of Tij and Vj. So let us substitute UI with Tij, Vj. So that is dou xi by dou x prime alpha. So UI is given by Tij, Vj. So Tij, Vj. Okay, this is fine. Okay, I think the color is too light. Let me change it to a darker color, maybe black. So this implies T prime alpha beta. This is the left hand side. B prime beta. We are simply rewriting the left hand side. And let me write the last term on the right hand side. That is dou xi by dou x prime alpha. Okay, Tij, Tij. Now let us write the transformation rule for this Vij. Vj hariba contravariant vector sigi transformation rule yangase. So let us look at the transformation rule for Vj. And since Vj is a contravariant tensor of rank 1, that is Vj is a contravariant vector, then its transformation rule is this: dou xj divided by dou x prime beta V prime beta. This is the transformation rule for Vj. Why are we taking the transformation rule for Vj? Because I have V prime beta on the left hand side, so I also want V prime beta on the right hand side. And if I want the component of V in the prime frame, I take the transformation of V from the unprime frame to the prime frame. Okay, this is fine. Now let us bring the terms on the right hand side towards the left hand side. So this implies T prime alpha beta. You see, we have one V prime beta here and another V prime beta here. So we can take this factor common. So what do we have here? T prime alpha beta minus, so this first term, dou xi by dou x prime alpha, dou xj by dou x prime beta, V prime beta equal to 0. So I have taken the terms on the right hand side to the left hand side and I have taken V prime common. Can I go? Now you look at the given condition here. The given condition is that V is an arbitrary contravariant vector. V is an arbitrary contravariant vector. So here V prime beta, these are the components of an arbitrary contravariant vector. Okay, so we are multiplying a term, an object which is inside the bracket with an arbitrary contravariant vector, and then we are contracting over beta. And if this is equal to 0 for every arbitrary V, got this is equal to 0 for every arbitrary v that we take, then there is only one possibility. And what is the possibility? The possibility is that the term inside the bracket should be equal to 0. Okay, so that is the only possibility, because here this condition is satisfied for every arbitrary v. So since v prime beta is arbitrary, so let me write it here. Since v prime beta is arbitrary, its coefficient should be 0. Its coefficient equal to 0. Therefore, there is only one possibility. The possibility is that the term inside the bracket should be 0. The term inside the bracket 0 means, can write it like this. Okay. So we can write it like this. That means T prime alpha beta is equal to dou xi by dou x prime alpha multiplied by dou xj by dou x prime beta. Oh, sorry, I am missing one Tij here. Tij. Okay, times Tij. Now, if you look closely, this is nothing but the, so which is the transformation, equation for a second rank covariant tensor. So if you look at this closely, this is nothing but the transformation equation for a second rank covariant tensor. So this particular statement, it proves that Tij is a tensor, and not only that, it follows the transformation rule for a covariant second rank tensor. So from this equation, we see that Tij is a tensor and it is a covariant second rank tensor. I'll pause the recording.